Let's take a look at the water molecule. Water is a polar molecule by virtue of the fact that hydrogen and oxygen from which it's made have different electronegativities. Here we can see the two hydrogens attached to the oxygen. Oxygen is in group 6 and is on the right hand side of the periodic table. Hydrogen is on group 1, which is on the left hand side of the periodic table. Oxygen only needs to gain 2 electrons, hydrogen needs to lose 1. Therefore oxygen is more electronegative and hydrogen is less electronegative. Oxygen would like to gain electrons, hydrogen in this case would like to lose electrons. This means that oxygen will pull electrons from the hydrogen-oxygen bond towards the oxygen itself. We can see this represented by these bond polarities using the arrows leaving the positive end of the arrow towards the hydrogen. We can also see that there is a partial positive charge, the delta positive, near the two hydrogens represented by the blue area, and a delta negative, a partial negative charge, towards the oxygen represented by the red area. The two individual bonds are both polar, and they both point in the same direction. They reinforce each other to give an overall molecular polarity. This is shown by the bigger arrow pointing generally from the hydrogen end of the molecule to the oxygen end of the molecule. The delta positive and delta negative charges on water allow it to dissolve ionic solids. Having polar bonds does not necessarily make a molecule polar. For example, let's take a look at CO2. Carbon and oxygen both have different electronegativities. Oxygen is in group 6, carbon is in group 4. Oxygen is further to the right of the periodic table than carbon. This means oxygen is more electronegative and carbon is less electronegative. In terms of bond polarity, the oxygen pulls electron density from the carbon-oxygen bonds towards itself, leaving the carbon with a slight positive charge and each of the oxygens with a slight negative charge. However, these two bond polarities are opposite to each other, which means they cancel. There is no overall polarity to the CO2 molecule. A molecule with polar bonds may be overall non-polar if the bond polarities individually cancel each other. As a polar molecule, water is able to act as a polar solvent. Polar solvents are able to dissolve polar molecules, and in particular water is able to dissolve ionic solids. When we put an ionic solid into water, the positive end of the water molecule is attracted to the negative anions. The positive ends surround the anion and dissolve it in the solution. The negative side of the water molecule, the oxygen side, is attracted to the positive cations. In solution, the negative ends surround the cations. The attraction of the anions and cations in the ionic solid is replaced by the attraction to the delta positive and delta negative sides of the water molecule.
Presenting Amazingly Fantastic Chemistry Joke! Which one of these bears dissolves in water? The white one! It's a polar bear!